All right. Hi, everyone. I'm Alexander Attar, and today I'm going to be talking about creating interoperable EVM networks with the Holograph Protocol. All right. So eventually there will be as many blockchains as there are tokens, and that is there to say the limit is infinite. This is a belief of mine, and it might be a hot take, but it's kind of illustrative of the core issue that arises when anyone can spin up a new blockchain and those networks are naive of each other. So before we get into it, a little bit about me. About 10 years ago, I finished my master's degree in music technology program at New York University. Leading off from that, I joined a startup called Songtrust, which is a music royalty monetization and collection platform. I've kind of been interested in creators and the technology that supports them for a long time, which has kind of led me to this path at this point. I was there for a long time, for about 5 years, where I really cut my teeth as a developer in software engineering. Built out a lot of the back-end technology, worked on a variety of technologies, front-end, back-end as well, and got more interested in blockchain and crypto at that time, which eventually led me to think about how I could use new systems to better off creators, which I ended up finding a startup called Consensus at the time, around 2016. And through that, there was a project that they had recently started, just a couple of guys. It's called Ujo Music. So I was very interested in this and decided this was like the perfect place for me to take my interests. So I got in touch with them, ended up joining at the beginning of 2017, and basically fell down the rabbit hole of working in blockchain tech, and I've never left since. At Ujo, we built the first music, it was the first music blockchain platform. We created the first music NFTs, arguably some of the first NFTs in general. And we allowed people to create portals so they could create their own music stores. There was a couple, boom and bust cycles in 2017 and so forth. Eventually Ujo got paused, so I was still entrenched in blockchain systems, so I started working on Infura, which some of you might be familiar with. Basically started working on infrastructure for a while. I eventually left Consensus. I joined a team called Optimism. Got more and more just deeper down the rabbit hole, started working on L2s, various other blockchains, and started realizing kind of, okay, this is, there are gonna be many of these networks, similar to how we have subnets for Avalanche spinning up now. For a little bit, I went back to my roots at a company called Foundation, got more interested and focused on creators, and helped build many of the features for this NFT platform, if you're familiar with it. And what was notable and relevant at the time was, I think, to this is we built out the infrastructure to support custom contracts. Okay. All right, so I'll give a little bit of an outline before we start. I'm going to give you a thesis that we think of at Holograph, kind of the current state of the industry, what Holograph is about, why I'm here at Avalanche Summit. Then I'll go over kind of more workshop-y stuff, the architecture, talk about the operator network, and so on and so forth. Okay, the thesis. The future is multi-chain, and people, I think, will be chain agnostic. Almost nobody cares about what database they're using throughout the applications they use in their daily lives, and I believe the same will be true of blockchains. And that's because networks serve different purposes. Networks have varying security models, networks have varying bandwidth and throughput, and networks have varying associated costs. Therefore, networks serve different communities. I believe people should be free to create and interact in environments of their selection, and people should be free to operate and control their own economies, and people should be able to transact locally and own globally. The current state of the industry digital assets are siloed, digital economies are fractured, and digital communities are oftentimes disconnected. So here comes Holograph. Holograph is a digital asset interoperability protocol. With that, with Holograph, digital assets are deployed onto EVM blockchains of the creator's choice and combined with specific sets of standards enabling assets to be holographed freely between networks while maintaining their attributes. Holograph enables fungible and non-fungible tokens to move across EVM-compatible blockchains while maintaining their persistent smart contract address, the underlying data, and the token ID in the case of non-fungible tokens. Oops. Sorry about that. Okay, so supported networks. It actually supports all EVM networks. Of course, we have to deploy the protocol to each one that we end up supporting. At the moment, it's Ethereum, Polygon, BSC, and of course Avalanche, hence being here. Coming soon, there will be others. We intend to roll out some L2s this summer, Optimism, maybe Base, Arbitrum, for sure, and many more to come. And seeing as subnets can use the EVM as well, it's definitely an interest of ours that we'll be keeping in mind and hopefully chatting with some of you all about. So yeah, why Avalanche? I think the ethos is aligned. Avalanche community is supportive of chain-specific purposes and communities, which is something that we very much agree with at Holograph. I think it provides an opportunity for increased adoption of Avalanche, considering potentially maxis from Ethereum and other communities that might have not been interested in experimenting with Avalanche now have a way to deploy their contracts on all of these EVMs at the same time, and maybe there's an opportunity there for people to experiment without the fear of being locked into an ecosystem they're unfamiliar with. So I'm hopeful of that for the Avalanche community because I think it's cool tech. Usability. Avalanche is cheap, it's fast, it's interoperable, especially with the subnets included, along with the primary network. I personally do almost all my testing during development for Holograph with the Fuji testnet because it's so much more reliable than some of the other chains, especially Polygon. Polygon is very, very bad. Hope that doesn't offend anyone. Okay. Now this is probably gonna get a little bit more technical. I thought I'd just kind of dive into like the entire modular stack of Holograph, so I'm gonna have to pull up some notes because I can't see it here. But let's get into it. I don't know how well you can see this, but this is essentially a diagram of the protocol components. I think this is kind of important to understand how it works and how we're achieving what we're doing so far and allowing these assets to just flow freely between the different chains. So at the core of it, there's the Genesis, which I mentioned briefly, that it has to be deployed on every chain that we support. We've already deployed the Genesis on over 20 chains, so that gives us the ability to more quickly deploy the rest of the protocol to it. Of course, we can continue to deploy more Genesis contracts, but it's a little bit more involved as we have a variety of security mechanisms that we have to go through in order to do that. Once that's there, though, we can essentially run through our deployment plan for the rest of it. And at the top of it is sort of like the entry point contract. It's called Holograph, rightfully so. And it basically is like a universal address and enables getters for a majority of the other contracts throughout the protocol. The other big important one is the factory. All the contracts, whether they're for fungible tokens or non-fungible tokens, essentially go through the factory, and this basically clones it so that they can be deployed across all the different networks. So you would be able to select the networks that you want to deploy to. And it would be at the exact same contract address, which is very handy for aggregating information about your contracts. And of course, sending tokens between them because you have a secure way to like reference that it is in fact the same contract that you're interacting with. It also allows for enabling event subscriptions, custom contract bytecode, and custom initialization code. We also have a registry, which is a little bit further down there. The registry also has a reference of all holographable contracts that have been deployed. And it's basically like a central point to view information about these various contracts. The bridge is actually, the holograph bridge contains the code to allow the bridge in and the bridge out events if you want to move your assets between different chains. And the operator, which I'll get into a little bit more later when I talk about the operator network, but essentially operators are entities that facilitate bridge jobs. We also have a variety of standards enforcers. We've baked this directly into the protocol because we feel like there should be some level of control for the way that types of contracts are deployed to ensure that they're following the standards. This, I guess, is for both security and functionality. We don't want users to get rugged, but based on our protocol, due to interacting with contracts that they did not fully like understand or compliant with the standards. So we've sort of baked that in there. And the entry point to that is actually called a holographer. It's like kind of like a parent enforcer, which we've already enabled a couple different standards. Of course, ERC 721, ERC 20, we'll have 1155s, et cetera, and that this can be expanded upon or extended to. Since we're dealing with non-fungible tokens on the Holograph Protocol as well, we've done a good amount of work on royalties. So we have a royalties enforcer, and that basically allows users to collect royalties from their contracts if they're NFTs, regardless of where they've been sold. And then interfaces basically just used to share the standardized data. And then finally, at the bottom, you can kind of see some of these are more in green. This is kind of important because we've built it in a modular way that allows you to like extend the protocol. Like I was saying about the enforcers, we don't necessarily build in all the functionality for whatever you're trying to do with your contract. So you can actually build these custom implementations and extend it however you want, which we've done recently for holograph open editions, and we'll have drop NFTs as well, which is a more unique circumstance that developers might aim for. That's it, pretty much. So with that, yeah, I'll get into the operator network, explain a little bit more about how that works. So moving assets between chains is definitely a challenge and has different trade-offs depending on the way that you're trying to go about it. And we've tried to address that with Holograph, but some of the problems include the security, generally locking and creating wrapped assets on different chains creates a honeypot on the origin chain and includes a number of other security pitfalls. It's also a UX hurdle. Bridging in traditional setups can require 4 or more transactions to move assets, and the user must own both chains' native gas token in order to make the transfer. Time consuming. You can have gas failures or other issues, or just get locked up with other problems and not end up being able to complete the full transfer. And it's also an interoperability issue. Moving assets to new chains often results in them being minted on new contracts at different addresses, which makes it difficult to maintain, aggregate the data, and monitor the assets, which is another big problem that we're looking to fix with Holograph. Okay, solutions. So yeah, we employ the use of the operators, which is a network of ecosystem participants who execute the bridge transactions for users. This reduces the friction when bridging tokens. It reduces the number of transactions needed to complete the process, removes the need to switch networks, and removes the need to manage multiple gas tokens. All right, now we're getting a little bit more into the weeds, but the way the bridge flow works is that, well, the right to perform work on Holograph is made possible through the use of protocol's native utility token, which is HLG. Users make bridge requests from the origin chain to destination chains of their choosing. The request encodes the call data to simultaneously burn the asset on the origin chain and mint it on the destination chain, so there's no locking in our protocol. The request is initialized, the token is burned on the origin, yeah, so on and so forth. I already said that. Operators are notified of the job and randomly are selected to execute the job. Operators bond HLG to earn the right to perform the work, so they need to get that HLG first. Operators who fail to perform this work will have their bonded tokens slashed. So it's essentially bridge mining. Operators are rewarded the H tokens in exchange for their services. H tokens are basically just wrapped assets of the origin chain. So it can be lucrative if you think about it. And if, yeah, as I said before, if one operator fails to execute job, it's passed along to the next one, with Holograph at the moment acting as the operator of last resort. We built a CLI for this. We haven't opened the operator network up to everyone yet, but we will be, probably aiming at Q3 of this year. So I'm pretty excited about this, and we're excited to get this into the hands of more users, hence the reason why I'm talking to y'all about it. Maybe some of you will want to download the CLI and try it out. But yeah, it essentially allows, it's designed to listen to, select, and execute bridge transactions. An operator must configure the CLI on every blockchain they want to execute jobs. So you have the choice. You get to pick the networks that you're operating on. It's a custom client. You select your blockchain, deposit the selected blockchain's native gas token, bond your HLG, and then basically execute the bridge transactions as you get selected, which means you have to remain online. So there's some maintaining this. The way the job selection works, basically to execute them, you must join a pod, is what we've called it. Each pod provides a different probability of selection based on increasingly higher minimum bond requirements. The probability of job selection is based on the specific pod being joined and the number of operators bonded in the specific pod. A little bit more details on that. There are a few concise rules of how jobs are randomly assigned and operators are selected. If a pod operator limit is reached, the bond amount increases with each new operator. There are no limits to the number of pods that can be available. An operator can participate in one pod per network at any given time. Each time a new job is made available, one pod is randomly selected. Once selected, one random operator is selected to finalize a job. When an operator is selected for a job, they are temporarily removed from the pod until they are completed the job. Basically, their tokens go into escrow. If an operator successfully finalizes the job, then they earn a reward and are placed back into the pod. All right, this is basically the anatomy of a holograph bridge job. It's pretty simple. It's basically a concise struct that has the number, the block times, the operator's address, start block, and start time stamp, and then the fallback operators, which at the moment we have it set to 5, which should be enough considering we're also going to act as the operator of last resort. And that's basically it. I had previously planned thinking the format of this workshop would be a little bit different, and we'd be able to get set up with the docs to go through becoming a holograph operator. But I'll be here throughout this week. If you're interested in this, please come talk to me after this. And if you want to get set up becoming an operator, we can do it on a more one-on-one type basis. Love to help you guys get set up. So yeah, that shortens my workshop a bit, but that's it. Thank you. All right. Any questions?
Can you send messages through this protocol or just NFTs and tokens?
Pretty much tokens at the moment. We do have a message relayer layer, but it's the way the rest of the protocol is designed for digital assets, not like what type of messages are you thinking of?
If you wanted to activate something on another protocol by sending in a message to, like, say, sell on Ethereum, or when if this happens on Ethereum, then do this on Avalanche.
Okay. In theory, it's possible. It would depend on like essentially creating those like custom contracts, and you can tie those into the bridge in and bridge out functions that we have in the protocol, and it would basically get sent through the message relayer, which at the moment we're using layer 0 primarily. We have built that in a modular way that allows us to swap those in and out, and have been talking to Hyperlane and some other message relayers as well. But that is an interesting concept, and in theory could be possible. So, sorry, what did you say? Fees. It's dynamic actually, so it depends on the current like gas prices. Layer 0 themselves charges a small fee. I actually don't remember the exact amount off the top of my head. No, the operators do earn a bit of fees, but it's essentially whatever is left over from the gas that is supplied after it goes through whatever gas is used, whatever the gas that layer 0 takes. They basically like collect the change. Yeah. Anyone else? Yes. We've essentially made it so that during transfer, or like there's essentially like a block on transfer based on if the royalties are enabled. Yeah. Yep.
Sorry, what's your roadmap for 1155s?
1155s. We don't have a specific roadmap for it at the moment. It is fairly easy for us to introduce it. We do have a number of priorities we're pushing pretty hard for at the moment, but it is something that we're interested in bringing on soon.
You mentioned the bridging burns on one side and it's on the other.
Mm-hmm.
So how does the reverse go if you burn the original token? Say like you've got Link and you're sending it from Ethereum to Avalanche. How does the reverse go?
It works the exact same way in reverse. So you could move your tokens back and forth, and it'll just spin up. And in the case of NFTs, which is particularly cool, is that it maintains the same token ID. So yeah, basically just. Also, it's worth noting that transaction, like it's doubly like encoded. So if for whatever reason that fails, like the mint transaction is part of the burn transaction, so it can essentially be replayed. So you don't need to worry about losing your asset.
You mentioned the slashing of the tokens of the operator when they do not send the final transaction, but can they send a malicious transaction? Because like, how do you? Is there control on the chain itself or on the operator software itself?
No, they're basically essentially just executing a job that already is encoded. So there's nothing else that they can inject into that job. Yeah. The message is created through the protocol, and it's static at that point.
So if they change the encoded data, it will be rejected on the on-chain?
Yes.
Okay.
Yeah, that's correct.
So you can use this protocol to interconnect like private blockchains with public
That's true, yeah. Although it does require deploying the protocol to the private chain, but this is like one of the key things that we've kept in mind, and like part of the interest of being here at Avalanche Summit with the interest in subnets and whatnot. I think it's potent. Anyone else? I think we're just about out of time anyways. Cool. Thank you all.